Section 8.1.33-T. In the game of roulette, a wheel consists of 38 slots numbered 0, 0, 0, 1, 2, all the way to 36. To play the game, a metal ball is spun around the wheel and is allowed to fall into one of the numbered slots. If the number of the slot the ball falls into matches the number you selected, you win $35. Otherwise, you lose $1. We want to complete parts A through G below. Part A, we want to construct a probability distribution for the random variable x, the winnings of each spin. Okay, so the first thing we need to do is there is an equal chance of the ball falling into any slot. Determine the number of slots that correspond to each winning amount and divide by the total number of slots. Do not overlook slots 0 and 0, 0. There are two possible amounts to win. The probabilities of winning both amounts are going to be the following. So what we have is we have x, okay, and then we have the frequency, and then the probability of that occurring. So we have two possible amounts to win. We have either $35 or we can lose $1. Okay? Now, if we count up all these numbers from 0, 0, 0 to 36, well, that's 36 plus 37 plus 38. So what that means is that there's one chance of winning the $35, which means that's 1 out of 38. Okay, and then we want to figure out what that probability is. Now, how many chances can you get -1? Well, -1 means that out of all the other possibilities, you can get 37. So that's going to be 37 divided by 38 for the probability. Okay, so let's go ahead and find that probability. So if we take 1 and we divide that by 38, then that gives us, we're going to round it to 4 decimal places, 0.0263. So 0.0263. And then if we take 37 and divide that by 38, then that gives us, rounding it to 4 decimal places, 0.9737. So 0.9737. So let's take a look at this right now. Okay, you get one chance winning out of 38. That means if you put this as a percentage, that means you have approximately 2.6% chance of winning. And over here, you have a 97 possible 0.4% of losing. Okay, so therefore, this is our probability distribution for the random variable x. Okay, so now what we want to do is we want to determine the mean and the standard deviation of the random variable x. And then we're going to round our results to the nearest penny. Okay, so what we want to do, okay, is we want to be able to put this in a StatCrunch and then just easily determine, okay, how many and what our mean and our standard deviation is going to be. So here, we're going to go into StatCrunch. Okay, so what we're going to do is we're going to list our values. Okay, what are the chances of winning? Okay, so how many -1s do we have? Well, we have 37, so we're going to put -1 37 times. Okay, so what I've done is I put -1 in here 37 times, and then the 38th possibility is going to be 35. Okay, so now that we've done that, okay, what we want to be able to do is now that we've done that, now we want to be able to then determine what is the standard deviation and the mean. So we're going to go to Stat, Summary Stats, and select Column. So we want to select the variable 1 column. We want to find the mean. Okay, now in this scenario, we don't want the standard deviation. We want the unadjusted standard deviation. So we want to hit the control button and hit the unadjusted standard deviation. And then we're going to select compute. So let's go ahead and do that. We're going to write down what our mean is and our standard deviation. Okay, so now that we've done that, we know that we have our mean, which is negative 0.05 rounded to 2 decimal places, and then our standard deviation rounded to 2 decimal places going to be 5.76. Okay, now, next question states that suppose that you play the game 50 times, so that n is equal to 50. Describe the sampling distribution of the sample mean and the mean amount 1 per game. So what we need to do is we need to find the mean and the standard deviation of the sampling distribution. So recall that the mean of the sampling distribution is also going to equal the population mean. So we know that that's equal to negative 0.05. Okay, and now we also want to find the standard deviation of the sample mean. So we know that the population standard deviation is 5.76, and we're given the fact that n is going to equal 50. So using our formula for the standard deviation of the sample mean, we know that's the population standard deviation over the square root of the sample size. So we know that this is going to be 5.76 divided by the square root of 50. Okay, so let's find this on the calculator. We're going to take 5.76 and we're going to divide that by the square root of 50. And so let's go to 6 decimal places. So we got 0.814587. So 0.814587. Okay, so that is the sample standard deviation of the sample means. Now, in Part D, it's saying what is the probability of being ahead after playing the game 50 times? That is, what is the probability that the sample mean is greater than 0 for n is equal to 50? So what we're looking for is the probability of when x, the sample mean, is going to be greater than 0. So to make a visual description of this, we create our bell curve, and we know that the mean is negative 0.05 that we found in part 1, and we have the value of 0 and everything to the right, so we want to find the probability there. So we're going to use technology. So the first thing we're going to use is going to use our calculator. So in order to find that area, we're going to use our normal CDF. The lower number, or the lower bound, is 0. The upper bound is 9999. We know that the mean is negative 0.05, and the standard deviation is 0.814587. So let's go ahead and put that in there. So we have second distribution, normal CDF. We have 0 as our lower bound, 9999 as the upper bound. The mean is negative 0.05, and the standard deviation of the sample means is 0.814587. And so that gives us a result of 0.4755. So that gives us 0.4755. Now I'm going to come back up here. Now in part 2, they may ask you to round this to the nearest two decimal places. So that'd be 0.81. But you want to use this when you're going ahead to solve for the probability. Okay, because it might throw off a decimal here. Okay, so now what we want to do is we're going to go ahead and then we're going to do this on StatCrunch. So we're going to go to calculators and then normal. Okay, we know that our mean from our example there is negative 0.05. We know that our standard deviation is 0.814587. And we want to make sure that it's greater than 0. And so therefore there it is computed. And now we can see how we would solve for that on StatCrunch to get the same probability. So therefore we can see what the probability is. It's approximately about 47.55%. Okay, now let's take a look at part E. Okay, so this question says, what is the probability of being ahead after playing the game 100 times? Okay, so what that means is we need to first, again, find the mean of the sample means, and we know that's the sample, that's the same thing as the mean, which is negative 0.05. And then what we want to be able to do is find the standard deviation of the sample means. So we know the standard deviation at the beginning is 5.76, and here we know that the sample size is going to be 100. So in order to find the standard deviation of the sample means, it's going to be the standard deviation over the square root of the sample size. So we have 5.6 divided by 100. Okay, or the square root of 100. Okay, which becomes 5.6 divided by 10, which gives us 0.576. Okay, so we want to find out what is the probability of being ahead after playing the game 100 times. So now what we're doing is, in the same question, we want to find what is the probability that the sample mean is going to be greater than 0. So again, when we draw our picture, what we're looking for, again, is that we have our mean at negative 0.05, and we're looking for the area that's shaded to the right of 0. Okay, so again, we're going to use our calculator or StatCrunch. So we have normal CDF, our lower bound number is 0, our upper bound number is 9999. We know that our mean is negative 0.05, and now our standard deviation of the sample mean is 0.576. So let's go ahead and plug that in there. So normal CDF, we know 0 is the lower bound, 9999 is the upper bound, negative 0.05 is the mean, and the standard deviation of the sample mean is 0.576. So let's go ahead and take a look at that. And so if we round that to 4 decimal places, then we get 0.4654. So that's about 46.54%. Now, if we want to do this on StatCrunch, we know what our mean is. We know we want it to be greater than 0, but we just need to change the standard deviation to 0.576. And then if we hit compute, we're going to get the same probability that we got with the calculator. And so therefore there is the probability. Okay, now let's take a look at part F. So for part F, we want to find out what is the probability of being ahead after playing the game 500 times. So again, we know that the mean of the sample means is negative 0.05. We know that our population standard deviation is 5.76, and now the sample size has now become 500. So now we want to find the standard deviation of the sample mean, which is 5.76, and we're going to divide that by the square root of 500. Okay, so what do we get for that? If we take 5.76 and divide that by the square root of 500, so 5.76, divide that by the square root of 500. So let's go all the way to 5, so 0.2575, so 0.2575 and 95. Now we can round that to 2 decimal places, but we want to make sure that we use all of it when we're going to have when we put it into our calculator. So again, in part 3, we want to find the probability that the sample mean is going to be greater than 0. So again, we're using our bell curve. Same thing we did up there. We know that our mean is negative 0.05. And we also know that we're looking for the shaded area that's greater than 0. So now let's take a look at this. So we have normal CDF. We know that our lower bound is 0, our upper bound is 9999. We know that our mean is negative 0.05, and we know that our standard deviation is now 0.257595. Okay, so again, let's go ahead and plug it into our calculator. Second distribution, normal CDF. We know that 0 is the lower bound, 9999 is the upper bound. The mean is negative 0.05, and the standard deviation is 0.257595. Let's go ahead and find that. So here we get the probability rounded to 4 decimal places is 0.4230, or if you wanted to go the StatCrunch route, then we know that the mean is negative 0.05. We just need to change the standard deviation to what we found it to be, which is 0.25795, and then we get the same probability there with the exact picture that we drew in part 3. Okay, so there you go. Now let's take a look at part G. It says, compare the results of parts D through F, and what lesson does this teach you? It says, examine the effect of n on the different probabilities computed to determine what lesson can be learned. Meaning that, okay, let's start here in the first one. If you play the game 50 times, what is your percentage of winning? Well, it's about 47.55%. If you play 100 times, what's your percent for winning? 46.54%. Okay, if you play it 500 times, it's 42.30%. So let's go ahead and write that down. Okay, so we know that in part D, if you play the game 50 times, then the percentage of winning from our probability is 47.55%. If you play the game 100 times, then the percentage of winning is 46.54%. And if you play the game 500 times, then the percent of winning is 42.30%. And then you answer your question accordingly.